Okay. Suppose I said to you I had a business and the total cost of that business, TC, equals Q squared plus 7Q plus 23. Can we find the marginal cost? Well, that would be DTC dQ. That equals 2Q plus 7 plus 0. So 2Q plus 7 is the marginal cost. Is that exciting? Now, and we're going to do this over and over again in the history of our life, if this and that go together, this is marginal revenue. This is marginal cost. To find the profit max, I set marginal revenue equal to marginal cost. Well, now I know how to find marginal revenue and marginal cost if I have a total cost equation and a demand curve. Yes, it does not get much more exciting than that. Yeah. So we have what's called the sum difference rule. And you could make a joke about that if you think about SOME versus SUM, but I'm not doing that because why would I do that? It just says first derivative of fxx plus gx, f of x and g of x, dx equals derivative fx dx plus derivative gx, that's a d, dx. Yeah, and we already kind of did this, right? So if this is a plus or minus, we can make that a plus or minus, and we're good to go there. All right? And we've already done this, right? So if f of x equals 12x to the fifth minus 4x to the fourth, what we do? Well, we're going to split those guys up, right? We're just going to do this one separately, right? We're going to say that's f 12x to the fifth dx minus f prime 4x to the fourth, right? Yes? And so dfx dx, that's a d, is 60x to the fourth minus 16x cubed. Okay? Is that exciting? Yeah, you're like, yeah. You could do a really simple one. Take 9x squared minus 3, and then say, call that y dx. And you break that up, and so you're going to do the derivative of 9x squared dx minus derivative of 3 dx, right? Well, that's 18x. That's 0, and that's the answer. Okay? So I'm going to write the magic word. Well, I wrote it bad. Yes, we're going to practice. And once you're practiced at this, it's like, yeah, it's nothing. Now here's a little bit of a harder one, and this is multiplication. Okay, it's called the product rule. Okay, so if f of x equals gx times h of x, then that's going to be equal to gx times the first derivative of h plus g prime x times hx. Yay! 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 All right, simplest one possible, 3x squared. That's f of x. Okay, that means g of x equals 3, and h of x equals x squared. All right? So g of x is 3 times the first derivative, hx, would be 2x, plus the first derivative of g of x, the 3, which is 0, times x squared, means I get 6x. In other words, I pulled that down. We already been doing that, right? But we know to do that from the product rule. We just tell you to do it before we explain to you why you should do it. So how about this? How about f of x equals 3x to the 4th times 2x minus 5? Okay? Everybody with me on this? So g of x equals 3x to the 4. H of x equals 2x minus 5. We good there? So the answer to this is 3x to the 4th times the first derivative of that, which is just going to be 2, plus the first derivative of that, which is 12x cubed, times 2x minus 5. And you say, okay, that's the answer. Now we can multiply that out together, and that's 6x to the 4th plus 24x to the 4th minus 60x cubed, right? Which is 30x to the 4th minus 60x cubed. Okay? That's the first derivative of that. Now, can we prove that? Can we prove that? Did it work? 3x4 minus 2x times 2x minus 5. That's a times. Well, let's multiply this out. So multiply this times that, and you get 6x to the 5th minus 15x to the 4th. Do we all get that? 2x times 3x is that. And 3x to the 4th times minus 5 is 15x to the 4th. Take the derivative of that, and we get 30x to the 4th minus 60x cubed, which is exactly what we got over here. Is not that exciting? The product rule works. We are so excited by the fact that the product rule works. Are we not? Yes, we is. So now, let's do what's called the quotient rule. So let's suppose that f of x equals g of x divided by h of x. The answer to that is more complex. The answer to that is hx times g prime x minus g of x times h prime x over hx squared. Oh, you're like, no, I didn't want to do this. They made me take this summer. All right, suppose that f of x equals 5x cubed over 4x plus 3. Okay, what's the slope of that baby? What's the slope of that baby? Well, you've got this formula, right? This is h, and this is g, right? Yeah. Yeah. So let's do it. 5x cubed, 4x plus 3. So f prime x is going to be 4x plus 3 times the first derivative of that, which is 15x squared, minus 5x cubed times the first derivative of that, which is 4, divided by 4x plus 3 squared. Yo, baby. That is exciting. Okay? The odds of you ever doing something like this in real econ is small, but you got to know the rules. You got to know the rules because you do something without the numbers you're doing. You would do an ax to the n, or you'd do a generic one of these as you were setting up a model that you were doing. Okay? We might not make you do the, we might not make you do the actual, no? Okay, do you want to do just a simpler one of those? So say f of x equals, let's keep the 5x cubed, right? No? See, if you put like 3x squared here, we can simplify that, right? That's 5/3 x. So the ones that look like this are always, yeah. So if we go 5x cubed plus 2 over 3x, let's just do that one. Okay? What do we get? Well, we get 3x times 15x squared, yes, minus 5x cubed plus 2 times 3 over 3x squared. Make sure you don't just square the x. Make sure you square the whole thing, right? These things are no fun. A lot of these are simple and you just simplify them. Now we could multiply this all out and do whatever with it, but we're not going to do that. Okay? Okay. So what we've been doing is what's called the first derivative. What we need to do now is something called the second derivative. The second derivative is the derivative of the first derivative. Yeah? So let's take x to the fourth. Okay? So, f of x is x to the fourth. F prime x, the first derivative of x to the fourth, is 4x cubed. The second derivative of x to the 4 is 12x squared. You're like, why? So this is the slope of this function, right? This is the function. This is the slope of the function. This is how the slope is changing. Yeah. Let's look at a couple graphs. Let's look at that. Okay. So let's just say that's x squared. All right, that's the function. The slope at any point on there is 2x. So if this is 4, this would be 16, right? This is x, and this is y. And the slope of the line right there, we take that point, right, and we draw the tangent line through it. The slope of that tangent at 4 would be 8. So it comes out 1 and up 8. The second derivative would be what? It'd be 2. What's that mean? It means that the slope is increasing, because this is a positive. The slope is increasing. And it's increasing at a constant rate of 2. So if I go out to 8, at 8, this line would be at 64. And the slope at 8 would be 16. The slope here was 8. Yes? Yeah. We've gone out 4. And the slope has gone out by 8. 2 times... Yeah, look, it's so beautiful. Everything is beautiful in its own way. How about that one? Well, let's not do numbers. Let's just talk our way through this, shall we? It's increasing. Go back. This is increasing, right? And it's increasing at an increasing rate. It's getting steeper and steeper and steeper and steeper and steeper as we go up. That's because of that. Okay? It's not because of that. It's because of that. This is increasing, but it's increasing at a decreasing rate. So if we do this, we'll have a function, right? F of x would be the slope. Second derivative would be negative. Because the slope is getting smaller and smaller and smaller, heading toward 0. Okay.